I feel like archery is a very popular sport with engineers because a lot of us like the physics of it, like the force and energy from the limbs, and we've actually used it a couple times in different classes that we've taken here at Berkeley. And pretty much, it's a lot of fun. You see it in movies, and so the combination of having both the aspect of fun and being something we enjoy doing, and also having the whole math and engineering and physics behind it, make it a really attractive sport.
One, two, three, go!
50% of the club is actually made up of engineers, and I think engineers like it because it's a precision sport. There are many different factors that result in a good or bad shot, and the key is breaking down your shot and finding out where it's best and where it's worst. So it's just about that problem-solving effort.
I decided to major in engineering because in high school I was good at math and science, and when I was even as a child, when I had things that were broken or like electronics, I would open them up and try to fix them on my own, much to my father's displeasure at times. But basically, they told me, you know what, if you like this in school, that means you'll probably enjoy it in life, so I decided to choose engineering. I chose to attend UC Berkeley because it's the #1 public school and #1 EE program in all of the United States.
The living environment at Berkeley is also really positive. I mean, there's always something going on. There's always a club hosting some event or a rally going on for something somewhere.
The advisor for Cal Archery is Professor Dennis Liu, also the Associate Dean of the College of Engineering. He was actually the one who taught all the founding members of Cal Archery how to shoot.
I actually knew Professor Liu as Dennis first through the archery club. I really didn't know he was a professor.
This is a recurve bow.
This is the compound bow. It is different from a recurve bow.
The further you pull back the string, the more force you get.
It has these things called cams.
When you release the string, all the energy from the string travels into the arrow.
What's different about the compound bow that the wheels provide is that at the end of the draw, there's a forced let-off.
The actual total amount of energy is the area underneath the force displacement curve.
Feel the maximum weight right about here, and then it drops down to about anywhere from 60 to 80% below the original weight.
The limbs attached to the riser here are actually a composite made out of wood and carbon. Then you have the stabilizer here, which is actually a composite of carbon and aluminum.
This allows for a lot more of the energy to go into the arrow.
The riser here is made out of aluminum. It's been forged for strength and post-machined for precision.
By a 4-axis NC mill.
This is a carbon aluminum arrow. It actually is straight within 50 microns.
This is the riser. It is carved from a solid block of 6061 T6 aluminum.
When the arrow leaves the bow, it isn't a rigid body. It flexes and bends at its natural frequency. If it doesn't do so, then it won't clear the bow correctly.
Like I said, it's a precision sport.
My name is Vivian Chu. I'm a 4th-year electrical engineering and computer science major at UC Berkeley.
My name is Alex Gray. I am a 4th-year mechanical engineering student.
Go Bears!